identity works for all values. Okay? But an equation, which is what we're studying today, only works for certain values. So when I ask you to solve, the word solution means any values that make an equation true. Now, is it still possible to have infinitely many of them? Yes. Yeah, we can still have infinitely many solutions. It's just not everything, even if it's infinite. Is that weird? Okay. All right. So sometimes we just give an answer that's infinite solutions because it can be, or sometimes we restrict like the domain, or the interval is a better word for it. We restrict the interval where we want to, what solutions we want given, okay? So let me just make a note of that. For trig functions, solutions are either infinite, and the reason for that is because we keep going around and around the circle, right? Or restricted on a certain interval. So sometimes I might say just find the answers from 0 to 2 pi. Or just find the answers from 0 to 360, or something like that. Or if the question says find all real solutions, then that means what? Find the infinite answer. So the way that that's going to look on your assignment when you see that would be find all real solutions. That means you're giving infinite solutions. Okay? Or if I tell you find it on a certain interval, it's probably something like find all solutions from 0 to 2 pi or something like that. Okay, so that would be a finite number of solutions that fit in that interval. This would be an infinite number of solutions that's done by using a k, like plus k pi or however many, to make that infinite, because k is integers, right? It'll make more sense when we actually start to do some problems. Okay, let's do an example. Examples. Find all real solutions that satisfy the equation cosine x equals 1. Now, we just barely learned in section 4.1 how to do a problem like this, because we said we use the inverse and we go backwards. However, when we did section 4.1, we said we're dealing with functions, there's only one answer. What did I just get done saying right here? Infinite. Okay, so why do I keep changing my mind? Okay. Let's go back to something we've talked about before. If we solve x squared equals 36, what are the answers? Okay, but if x equals the square root of 36, what's the answer? What's the difference? This one's already been defined with the square root, so therefore it's defined as the positive square root of 36, so the answer is 6. This one has not been defined, we're simply solving for x. which means it could be 6, it could be negative 6. We don't know. Either one of those work in here, right? Okay, so what's the difference between saying find the inverse cosine of 1 and finding the values that make x true? So this is what we learned in section 4.1. Okay, and there's one answer because we're calling them functions. And that's the answer you would get when you use your calculator, for example, or just going backwards on the chart, but paying attention to those quadrants. So what quadrants did we say that cosine exists in? 1 and 2. So, but this doesn't really matter that it's 1 and 2 because it's always 1, and since it's positive, it's going to be 1. So what angle is it that gives that cosine is 1? 0. Good. So the answer is 0. 0 degrees or 0 radians, either way it's still 0, right? Okay. So is 0 also an answer to this one? Just like 6 was also the answer to this? Or wait, just like 6 was the answer to that, rather? I should be going the other way around. Okay, so just like the answer 6, that is the only answer of this problem, is also an answer of this problem, but there's also another one. 0 is an answer of this, but there's infinitely many numbers that will work. So help me figure out what they are. Okay, 0, what else? Is 181 or negative 1? No, slow down because, okay, you're throwing out values to me, but the cosine of 0 is 1, but the cosine of 90 is 0. The cosine of 180 is negative 1, and the cosine of 270 is 0. There's only one of those that actually works. Okay? But we're doing all real solutions, so we're going around and around and around and around the circle. So 0, 360, 720, Can we go back the other way? So, or we could do this in terms of pi. 2 pi, 4 pi, 6 pi. So how do we write that answer so that it's forever? 2k pi is the solution if I'm trying to give all real solutions. Does that make sense? Do you understand the difference between 4-1 where there was one answer and 4-2 where there's infinite answers? It's the same process, same exact process. It's just instead of focusing in on the correct quadrants, you do every quadrant that applies. And forever.
Is that easy?
I don't know. You have to understand the other thing before you do this, though. Okay, so what was our answer? 2k pi. If you want to think about that graphically, sometimes actually thinking about the graph helps. So let's think about what the graph of cosine is, just another way of thinking about solving it. So here's cosine equals 1, and that's at 0. And then cosine equals 1 again at 2 pi. And then cosine equals 1 again at 4 pi. Or if you go backwards, cosine equals 1 again at negative 2 pi. Right? Think of the graph if that helps. And you're trying to find every time that that cosine value hits that positive 1 value. That's your solutions. Does that make sense? Okay, let's do another one. I'm going to